Okay, in Lab 4, we want to start implementing some simple queries using Apache Spark. Today's lab consists of three sections. In the first section, we just implement very trivial uh, computations on data frames. In the next part of this lab, we will implement a word count application on Spark. And finally, in the third part, we will use MLeap or Spark's higher level machine learning library to implement a machine learning task predicting the property prices. So first, let's start with the first part of the lab and using some data frames for computations. We want to write some queries and some comments and some operations in PySpark. PySpark is an iterative shell for Spark. There are two ways to access this PySpark. The first way is to install PySpark on your local machine and anyway, write and execute the commands we will explain later on in today's lab. Or you can log into the cluster, to the head node of cluster, like what I am doing now, and then type PySpark. Once you issue that command, here you can see the command prompt of PySpark. So as we can see here, PySpark is an interactive environment for writing and executing Python commands and Python operations. So in today's lab, we will use this interactive environment to write our queries. The first query I'm going to execute is reading a text file which I have in this path, and I want to store the content of this text file in a data frame. So as we can see here, we have a spark.read.text transformation here, and this is a path to the input dataset. So the input dataset is a text. That's why here I have used read.text, because I'm going to read a text. And after that, Spark creates a data frame for me named text file, and store the data in this data frame. Okay, let's run this data frame. So I can copy and paste, or you can type the command here and then enter. So now I have a data frame named text file, including the data in this text file. You might ask how we can see the content of this data frame. There are several ways to display the contents of a data frame. Now I want to use show action to display the content of this data frame. So first I type the name of data frame dot show, and here it shows me the first top 20 rows in this data frame. So here, as we can see, we have a table including 20 rows and a single column. The name of this column is value. So each column in the data frame has a name. And here we have a data frame including some rows and a single column. The name of this column is value. Please note that by default, this show operation displays the first 20 rows in each data frame. As we can see here, the text file is in each row. The text in each row is truncated. So here we have some anyway, some dots here. It means that the text in this table is truncated. If we want to display full contents of each row, we can use the option truncate. And if we set this option to false, in the output, we can see here, we can see the full content of each row. So as we can see here, nothing is truncated. And we can see the full content of this data frame. And if you want to display a specific number of rows from this data frame, you just need to set the number of rows you want to display. For instance, here, I want to display the first 40 lines. So here I have text file.show and the number of rows I want to display. And as we can see here, we have 40 rows here, but truncated. If I want to show the first 40 rows and untruncated, I can merge these two options, and here I have all the 40 lines and untruncated in untruncated format. So with show operation, we can display the content of data frames. There is another action like show named take. With take, you can display the content of data frames, but you know, take will give you further information about the data frame. So please run this command in the lab and see the output of this command. Test file.first display the first line of. As we can see here, the first line of data frame is displayed. So if we put here show one, I have, you know, Apache Spark here, and here we can see Apache Spark. So it displays the first row in the data frame. The next operation is count. Count, like show, is an action. And this action returns the number of rows or the size of a data frame. So if here I issue text file.count, it returns an integer number. This action returns an integer number. In this text file, we have 105 rows. Now I want to introduce next transformation named filter. We use filter in Spark to select a special kind of special rows from the data frame. So here we have text file data frame. Using this filter transformation, I want to select some rows. But to select rows, I need to write a condition. Here I have the condition. These queries generally select all the rows from this data frame, including the word Spark. So in the new data frame here, we have a new data frame named lines with Spark. We have a data frame including all rows with the word Spark. To implement this computation, we use filter. And as I mentioned earlier, we need to define a condition, a type of condition here. To instruct filter, how select the rows from this data frame. In this filter, I use the column function contains. I call this function, or I refer to this function as a column function because this function performs some computation on columns. There are lots of methods doing some computations on columns. You can find the full list of those methods and functions in this link. So if you click on this link, you can find lots of functions or lots of column functions in this link. Now I want to explain how this contains function work. As I mentioned earlier, this contains is a column function. So this function performs some computations on a column. Here, I have defined which column I'm going to use. So as we can see here, I mentioned that from text file, select column value. If you remember, in the data frame text file, we have only a single column named value. So here I selected this value column. In fact, this text file dot value is a column object. So in Spark, we call this data frame dot the name of a column a column object. So here, using column object, I have selected or I have referred to this column named value in text file data frame. So now I have a column, this column, and I want to apply contains function on this column. Contains function creates a column. Now I want to explain this function using an example. So for instance, here we have input text file, input data frame. So the data frame is text file. Here we have value column. So here text file dot value, text file dot value. This is the column I have selected, and this is the values in the comment in the data frame set. If I apply contains Spark on this column, the output is another column. In fact, this contains function creates a new column. The values of each cell in this column is equal true or false. If in this text file.value column there is the word Spark, the cell value here is equal to true. So as we can see here, we have in text file.value the word Spark. So this cell value is equal to true. Here in the next row, we don't have any Spark term. So the value is equal to false. I like Spark. We can see Spark here. So the value of this cell is true. In the same manner, here we have false. And finally, true. So as we can see here, we selected a column in the data frame, and then this function creates another column like this, including some true and false values based on the data we have in this column, in the text file.value column. Now filter use this column created by contents function to select some rows from this text file data frame. So here we have text file dot filter, and inside this command we have a row like this. Filter select a row from text file which its corresponding row in the contents Spark column is equal to true. So now I want to create this lines with Spark data frame. In fact, this is the output data frame of this query. As I mentioned earlier, filter looks at the output of this contains method. If this method for this row has returned true value, the row is selected to the output. So here we learn a Spark and its corresponding cell in the new column is equal true. So this row is selected. In the next line, we have false. So filter ignores this line. The next line, I like a Spark. So here we have true, and this line is selected. And after ignoring Hadoop framework, parallel Spark. So here we have the output data frame. And as we can see, all rows from this data frame are selected which contain the word Spark. Okay. If you remember, in the lecture, I said that we can use SQL queries in Spark. In SQL, we have an operation named like. With like in SQL, you can apply patterns, text patterns on each row. So here I have defined a pattern. This pattern means that any word, any text, including a spark, any text, including a spark. So like here, for instance, in this text, I have a spark, but in this text, I don't have any spark. So this like operation returns true for this text, but return false for this text I have here. So I can use this like operation, which we have in SQL in Spark. As we can see here, value is here, the name of column in the data frame. Here we have text file data frame, and value here is referring to this column. Like, this is like operation, and then the pattern. So if you run this column, the output is exactly the same as this output. So you can try in the lab, you can one time execute this command and show the new data frame lines with Spark, and in the next time you can execute this query and display the output. And if you compare these two outputs, you can see that these two queries returns the same rows from this data frame. Now I want to implement a much more complicated query. Now, in the first step, I need to read a CSV file. Here we have a CSV file named 2015 summary.csv. This file, we have some flight data. The flight information about the destination and source of each flight, and the number of flights between source and destination. Anyway, in the following comments, I will show you what's inside this data frame and inside this data. So first, I use a Spark read to read and load this data set. So like before, a Spark read, and here, because I want to read a CSV file, I don't use text, but I use CSV, because here I want to read a CSV file. We have this CSV file on the head node cluster, so you don't need to transfer this file from your local machine to the head node cluster. I have already transferred this file, and you can find the input data set in this path I highlighted here. Here we have two options. We have two options. The first option infers the schema automatically from the data. So this data is a CSV file. Its schema automatically is inferred from the data by this option. Uh, I mentioned that in CSV file, we store the data in terms of table. So using this option, we instruct Spark to separate the data in each row and creates a data frame like a table. So this is what the option infer schema does. Just not convert a CSV file to a table to make it suitable storing in a data frame. The next option is option header. If we use an option header, we say we inform Spark that the first line in this file contains the name of columns. If I here I want to show the contents of this CSV file. If we have a look at the contents of this file, in the first line we have 3 names. Oh, sorry. We have 3 names. The first name, comma, second name, comma, and the last name. So with this option, we inform or we ask Spark to set the number of the name of columns to these 3 lines. So we have 3 columns in this CSV file, and the names of those columns are test country name, origin country name, and count. And after that, CSV and the path to the data. If I execute this command on Spark, I will have a data frame named flight data 2015. Now I can display the first 20 rows in this data frame. I don't know, for instance, here, the number of flights from the United States to Egypt is equal to 15. The number of flights from United States to Egypt is equal to 15. And we have more data in this data frame. And if I run count, there are around 256 rows. Exactly. This is exactly the number of rows in the data frame. Here, with this command, I have reduced the number of shuffle partitions. Yeah. I have set the number of shuffle partitions in Spark to 5. In fact, you know, by default, the number of shuffle partitions is higher. But with this command, I have decreased the number of shuffle commands. Please look at page 24 in this book. Spark, the definitive guide. You can find the reason why we need to, what's the benefit of decreasing the number of shuffle partitions. So as an exercise, please go through page 24 in this, the Spark, the definitive guide, and in your report briefly explain what's the benefit of decreasing the number of shuffle partitions. So you can find every detail in this page. In the book I have already mentioned. You can find this book on Google Book. Sorry, on Google Read. On Google Read, you can find this book and then go through this page number and briefly explain what's the benefit of decreasing these shuffle partitions in Spark. So this is an exercise, and please explain this in your report. As I mentioned earlier, in this flight data 2015, we have 3 columns. Sometimes we want to display, or we want to select one or two columns from this data frame. To select columns, we need to use select transformation in Spark. So here, if I write the name of data frame dot select, why dot select? Because I want to select 2 columns from this data frame, and here I have the exact name of these 2 columns. So this underline country, underline name, as we can see here, this is the exact name of this, and count, the exact name of this column. After that, I want to show the output data frame. So here I have a data frame including 3 columns. I create a new data frame including 2 columns named this country name and count. And these columns extracted from the original data frame, flight data 2015. And in the end, I display the 10 first row of this data frame. So as we can see here, we have only 2 columns here. So this column and this column are selected, and we have 2 columns, and we displayed the first 10 line from the new data frame. Here in this comment, I have used the exact name of column. But in Spark, we can refer to columns by column object. As I explained here, I mentioned that text.value is a column object. So it's like I don't know, you can consider this text.value as a pointer to a column. So there are different ways to point to a column. One of the ways is to put the exact name of that column. The other way is to use dot operation, like here, and like what we did before, text file dot value. We use dot operation to point to a special column, to a particular column. Here in select, here I use the name of column to point to a column. So here we don't have any column object. This is exactly a name, but we can refer to columns using a column object or using this dot operation. So here, as you can see, we have the name of data frame dot the name of column. This term is named column object. This column object point to a column. This is like a pointer. So instead of this name, if I put the flight data 2015 dot the name of column, I can refer to this column. So there is no difference between this notation and this notation. Anyway, generally speaking, there are some differences, but generally speaking, there is no differences. So you can refer to columns by their exact names, and because here we have names, we should put the names between two quotations. Or we can use dot operation to select a column. And one thing I should explain here. Here I want to refer to this column by dot operation. In fact, I want to write something like this. Flight data dot count to refer this column, but I cannot do that. Why? Because in Spark we have a function name count. So if I want to access to this count column using dot operation, a name clash happens. So the Spark mixed up this count with count function, and it's a kind of error in Spark. So instead of using dot, I have to put this count in a double bracket to refer to this count. Anyway, here I have explained two ways to refer to or to point or to select the columns. The first way is to use the exact name of columns, and you don't forget to put the names inside double quotation like here. But if you want to use column object, you don't need any quotation like here. But you should use dot. The next transformation is group by. We have group by in SQL as well. Group by group the rows by their values. Let's explain group by example. Here we have two columns, desk, country name, and count. And this is the columns I have selected. So with this select, I have selected two columns, these two columns, and they are the data for these two columns. And now I want to implement, I want to group the data based on the values in this column. So I want to group rows in this data frame using the data in this column. Okay, if I want to group by, so this command group all A values together and all B values together. So the output data frame will be something like this. A5. This is the output data frame. A5. Next A row is here. A3. The other one A6 and A8. They are all A's, and after that we group all B's. B, B, and so as we can see here, we have all A's together and all B's together. So this is this group by operation group the data based on this column, based on the values in this column. After that, we want to apply sum operation. Sum is a kind of aggregate function. Aggregate function accumulate all the data in a group. So here I mentioned that sum all the data in each group, but use column count, or I instruct Spark in each group accumulate or aggregate the data in column count. So I have here two groups, group A, group B, and sum accumulate values in count column. The output, the final output will be something like this. The first group is A, and if we sum 8, 22, if I sum all these four values, it's 22, 16, yes, 22. And if I sum count values in group B, 10, it is equal to 10. So the output data frame will be something like this. This is the output data frame. So as we can see here, in suppose flight data 2015 contain this data. I've selected two columns named test country name and count. Then I grouped the data based on the value in this column. And as we can see here, we have two groups, A and B. And then on each group, I applied some function to accumulate the data in count column. And the output data frame is the summation of the sum of values in these groups for count. And this is the output. So if we run this command, we can see, I don't know, for instance, here there were 118 flights to Sweden from different origins. But the total number of flights to Sweden in 2015 is equal to 118. So in fact, this query implements or extract the number of flights to each country in 2015. So in your report, you should explain that what each query performs. Like what I explained. This query shows the number of flights or the total number of flights to each destination in 2015. As mentioned in the lecture, we can write queries in SQL. So in fact, we can execute SQL queries in Spark. To apply a SQL query or a SQL statement, we should create a view of the data frame to make it a suitable name to be referred from SQL. We cannot refer to data frames directly in a SQL statement, but we need to create a view from that data frame to make it a suitable name for SQL. Here, this create or replace temp view makes this data frame suitable to be referred in SQL. In fact, we create a new view for this data frame to be used in SQL. So first I run this command to create a view from this data frame. Now I can refer to this view in SQL. If you remember, I implemented this query using methods in Spark. Now I want to implement this computation using SQL queries. So this query exactly performs what we implemented using this command. Oh, I should type it. So Spark dot SQL quotation. Then I should write select discount from, this is SQL query. As we can see here, we refer to the view we have created here. So I have created a view here, flight underline data underline 2015. This is the name of view I have already created. So here I refer to that view. This view is anyway, it contains all the data in flight data 2015 data frame, but it's a kind of view we can use inside SQL queries because we cannot refer to data frames in SQL. If here I put this flight data 2015, it doesn't work because I should create a view and then I should use that view. Okay, next command is group by, and finally this. And if you compare the output of this query with this one, you can see the output is the same. So here, like before, we have total number of 118 flights to Sweden in 2015. Okay, so please start going through the first section of today's lab. I will explain the next two sections later on. Okay. In the next section of today's lab, we want to implement word count application. If you remember, we implemented the word count application using Hadoop MapReduce. Today, in this lab, we want to implement the same application, but this time using Apache Spark. To implement this word count application, we need to use two modules, split and exploit. So as we can see here, we have imported these two modules to the PySpark. And as we can see here, I have used split and exploit functions in this query. If you execute this query on text file data frame, the output will be another data frame. The output will be a table including the occurrences of all words in the text file. So this query returns what we have implemented in Hadoop MapReduce. Now I want to further detail this query. I want to start from the innermost command we have here. I have here a split function. A split function take as input two parameters. The first parameter is a cell, or sorry, a column. And here we have, we determined how the words in a text are separated from each other. If you remember, text file data frame consists of only a single column named value. So in a split here, I selected the, or I pointing to this column here. So this is the text file data frame dot value. So it means that I have selected, or I am pointing to this column, and comma backslash s plus. It means that this is a pattern. This is a pattern and determining one or more space. So this split function split text in this row or in this column, in each row of this column, which are separated by one or more space. Now I want to explain what this split performs by an example. Suppose here we have the value column in this text file data frame. So this is column value, and we have two rows in this column. As I explained earlier, a split creates a list of words separated by one or more space in each row of this column. If I execute a split on this row, the output will be a list including all words separated by a space. So this is the first word. The next word is a test, and finally row. So a split takes this row in this column value as an input and returns a list, including 1, 2, 3, 5, 5 items. The next row here, we have this is a test, and here example. As we can see here, the data in this value column is separated using these two lists. After that, explode this explode transform these lists into some rows. So now I have as input these two lists. If I give these two lists to this explode function, this function will create a column. Each row in this column will be an item in these two lists. So this then is a test row, and now here I have another this, another is another example. By now, a split divided the data into some items in these lists. Explode transformed these two lists into a row. Now I have another command, alias. Alias gives a name to a column. So I want to name this column word. So the name of this column in the new data frame is word. Here I have separated words. I have created a column using the items in these two lists. After that, I give a name to the columns of this data frame. Now I want to apply work group by on this column. Like before, group by group the items in this column together. I have to this here, to is to A. As we can see here, we have two A's. I have to test, and finally I have one row and one example word. Here I have grouped the data, and if I issue count on each group, they are all suppose groups. So I have these groups. I have 1, 2, 3, 4, 5, sorry, 6 groups. I have 1, 2, 3, 4, 5, 6 groups. If I apply the function count on each group, the output will be like this. This is the final output. This is the final output I have in word counts variable. This and 2. Is 2, because the count function count the number of items in each group. So in this group, I have two this and 2, is and 2, A, 2, test 2. I have only one word in this group and one example word in the last group. So this is the output of this query. So please run this query, but I have explained this query using a very simple data set. Here we have a larger data set in text file. So please run this on the text file data frame to see how word count application is implemented using a single line. If you remember, we implemented this this application using mappers and function and reducers functions. But here in Spark, we can only implement this MapReduce application using a single line and a few functions, including select, exploit, split, alias, group by, and count. That's it. Okay, so please run this code and go through the details of this section. Here you can find the details of these commands we have used here. In the last section of today's lab, as promised, we are going to implement a machine learning job predicting the property prices. In this section, I'm going to use a data set from Kaggle. I have uploaded the data set in this path, as you can see here, /home/spark /mel data.csv. In this CSV file, we have a data set including some columns such as the number of bathrooms, the size of land, and the price of the property. We are going to use this data set to fit a model using random forest in Spark. Let's read the data and create a data frame. Now I have a data frame named Melbourne data. In this data frame, I have Melbourne data 10. As you can see here, we have address, price, distance, postcode, bathroom, land size, and other columns. Here we have some empty cells in the data. These empty cells make a problem for us. In fact, these empty cells, we cannot use these empty cells in our model because these empty cells don't have any useful data for us. So before creating the model, we should somehow clean up the data. I mean, we should somehow remove these empty cells from the data, from the input data. So these values are empty, and we should remove all of them from the data set. This step is named cleaning up. So before fitting the model and before creating any machine learning model, I should clean up the data. Before doing everything, I want to query the number of rows in the data. As we can see, we have around 30,500 rows. Now I want to clean up the data. To clean up a data frame, we use drop NA. Drop NA removes all empty cells and then purify the data. In fact, here, for instance, here in this row, we have empty cell. So this row will be removed. This row will be removed by drop NA. And this. So if I apply this drop NA on the Melbourne data frame, I will obtain a new data frame named Melbourne data clean. In this purified or clean up data, there is no empty cell. For instance, if I here show the data, as we can see here, there is no empty cell, and all cells contains a data. And if here I count the number of rows, as we can see, around 6,000 rows have been removed. So in the model we are going to create, we will use this cleaned up data set. You know that when you want to create a model, we need to create a feature vector. In this feature vector, we determines a set of parameters we are going to use as an input to our model. In this example, I want to use 5 parameters. These 5 parameters are the number of rooms, bathroom, land size, latitude, and longitude. So these 5 parameters, I'm going to use these 5 parameters to create a model. So I have to create a vector of these features, a vector of these 5 features. In this vector, I will have the values of those parameters, the values for those parameters in each row in the data set. So let's start creating the vector, and then I will show you how the value of this vector. What is the value of this vector? So to create a feature vector, I need to use vector assembler module. As you can see here, we should import this module to PySpark, and then to create a vector or to define a vector, we should run So now I have defined a vector assembler named vector assembler. Now I use this definition to create feature vector using this cleaned up data. So I use this cleaned up data to create a feature vector, and this feature vector will be somehow appended to the data set. So here I'm going to create a feature vector using the data in this data frame, and this command will create for me a new data frame. Now I want to display the first row of the new data frame I have created. Let me, here, this is the first row in the new data frame. As I explained earlier, we need to create a feature vector. And as you can see here, we have such a vector for each row. So this is the feature vector for the first row in the Melbourne data set. Each row in this data frame has the same feature vector. And the values for this vector is the values for rooms, because here I have created a vector including the number of rooms. So here, for instance, for this particular row, the value for rooms is equal to 2. So as we can see here, we have two. The first item in this feature vector is equal to 2. The next parameter is bathroom. Here, bathroom value in this row is equal to 1, and we have 1 here. The next parameter is land size. Land size value is 156, and here we have 156, and so on and so forth. So as you can see, using this vector assembler module, I have added a new column to the input data set, including a feature vector. So this is the feature vector we have created. Please note that mlib in Spark, you know that mlib is a library we use to implement a machine learning model. So mlib in Spark will use this feature vector to create the model. Okay, after creating this feature vector using this vector assembler, now I want to create the training and test data sets. You know that in machine learning, we need two data sets. We need one data set, one larger.
Hello.
Hello.
A quick question. I want to get clear with the feature vector.
Yeah.
The features that we are having as 2, 1, 1, 5, did you assign them yourself?
No, they are extracted from each row of the data.
Okay, the existing data.
Yes, the existing data, yes.
That's
So
fine.
here, I just briefly go through the steps again. So here I have a Melbourne data frame. After cleaning up, I have another data frame, Melbourne data clean. Now I want to create a now I want to create a vector, a feature vector, based on the data in this clean data frame.
Okay, I get
So
it. It's fine.
So as you can see here, I have defined the vector here. So this is the vector. Here I am defining that the parameters I am going to use in my model is rooms, bathroom, land size, and blah, 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 blah. So after creating this vector here, we can see that the feature vector for each row is created using the data in each row of the input data set.
Thank you. I'm okay. Thank you.
Yeah. Okay.
Thank you.
Okay. After creating these feature vectors based on the values in each row of the input data set, now I want to create the training and test data. You know that the training data set is larger than test data set. So to create these two data sets, I randomly split the clean data set. So here I use random split to split the data between two sets, training data and test data. Training data contains 70% of all data set, and test data involves 30% of whole data set. So the data set randomly split between these two data sets. 70% of data is given to this data set, and the rest, which is 30%, is given to test data. So now we want to use this training data set to create a model, to fit a model or train a model. In this example, I'm going to use random forest. Random forest is an algorithm to create a machine learning model. I should add this module to PySpark, and now I'm going to define the model. In this model, we have two parameters. Feature call is equal to the name of feature vector set. So if you remember, we created a feature vector for each row. So now we have a column in the input data set, and this column is a feature vector has a feature vector in each cell. So here we have the name of this feature vector. The name of this feature vector, or the name of the column, including those feature vectors, is features. So here we set the parameter feature column equal to the name of feature vector column. And the label column is equal to the column name price. Here in the data, we have a column. Yeah, here we have a column named price. So this is the price of a property. The price of a property. So with these parameters. The next row we have another price and for another property, and so on and so forth. Okay, so here in this model, we mentioned that the features, the input features, should be read from the column features, and the labels or the target values are available from this column named price. Okay, now I want to create this model. After that, here I have defined the model. So what's the input features and what's the goal or target, which is price. Because in this example, we are going to predict the price of properties. So the target is price based on the features in this feature vector. Okay, now I want to fit the model using training data. So this is the model, the random forest model, fit the function fit using training data. If I execute this command, what's the problem? Train data, because I didn't run this. So I should create the train and test data set. I have created my random forest model. Now I want to train the model. This fit method creates the model, train the model. So now training starts. Okay, now I have a model, so a trained model. To evaluate the model, I can use method transform using test data. So here I use the test data set I have already created. So 30% of whole data is allocated to this test data. Now I am using this test data to evaluate my model. So I have trained the model, and now I'm going to evaluate the model. Predictions is a data frame. In this data frame, we have two columns. One column is price, and the other column is prediction. In price column, let me show. Okay, this is the evaluation results. So as I mentioned, prediction and price. The price column represents the actual price. So this column is extracted from the input data set. But the prediction column is equal to the predicted prices. So these values in this column have been predicted by the model we have created here. So actual price, the predicted price. Actual, predicted. Okay, now you might ask how we can obtain the I don't know, the error rate of this model. To obtain error rate, we need regression evaluator module. So I add this module, then I create an evaluator, or I define an evaluator. So here the metric name I have considered is mean absolute error. And now I use evaluate function to find the mean absolute error of my model. And to show this value, I use this print command. And as you can see here, this is the mean absolute error of my model. Okay. You know that random forest explore a tree to fit a model. As you know, each tree consists of some levels. By default, mlib library in Spark creates a tree consisting of 5 levels. So as you can see here, the depth of tree created by mlib is 5. So when here I start fitting the random forest model here, this function creates a tree including 5 levels to fit a model. But you can increase the number of levels, or you can increase the depth of the tree to make a more accurate model. If you want to create a more accurate model, you should increase the depth of tree by this option. So when you want to create your random forest model, along with feature column and label column, you should set the number of depth in your tree. So in your lab, one time, please don't set the max depth and create the model and obtain its MAE. Then increase the number of levels in tree to 10 and fit your model and obtain its mean absolute error. And finally, try with 20 levels in the tree. And then compare the accuracy of your tree models. Yeah, this is what you are going to do in the lab.